So good afternoon, everybody. I'm delighted to have the opportunity to discuss with you the key findings of our stakeholders engagement activities as part of Project CAELUS. So I will start by sharing my screen with you so that we can all go together through, the slide deck to lay out those key findings. First, a few words about Project CAELUS. CAELUS is a research project selected as part of the UKRI Future Flight program. It's an 18-month program, and the objective of CAELUS is to assess and then demonstrate the viability of a drone-enabled logistics network to support the NHS in Scotland. The consortium is led by AGS Airports, and we are a team of 14 entities altogether working on the project that is coming to completion within a few weeks. Now, as part of the project, we decided to work on the technology aspects, but not only on the technology aspects, because promoting a novel use of technology such as a drone-enabled logistics network for the the NHS requires non-tech and soft issues of soft topics. So really the objective of our stakeholders engagement activities was to discuss with people and to collect their feedback as untainted as possible. We try to have an open conversation, to listen to people and not try and convince them at this stage, or not at all, really to collect feedback on perceived benefits, on concerns that they see for themselves or for the general public, and then as well shape out some recommendations in terms of how to address the concerns or overcome the roadblocks that have been identified. So we had engagement with a relatively broad range of stakeholders because we wanted to have a large view of things, of what people would think. We interviewed 26 stakeholders, organizations in total, and you see the range of it. Some from the US ecosystem, some from the UTM and enabling infrastructures, some from the local communities and environmental agencies, some from the regulator and the research funding, the healthcare ecosystem as well. And finally, last but not least, the bigger proportion of stakeholders were actually other airspace users, because we recognize that one of the key challenges in BVLOS, in flying beyond visual line of sight, will be the safe sharing of airspace with other airspace users. So that's why we really made sure that we would have a reasonably broad representation of other airspace users. Of course, we could not have discussions with everybody, but we did try to engage with a reasonable set of other airspace users to collect the feedback. And I have to say, I was really amazed. We had tremendous conversations, and the challenge in our exercise was not so much to identify stakeholders and engage with them, is to give the key challenge was to give justice to all the feedback that we collected. Altogether, we collected some 430 insights on our project. So that was, a really tremendous response from all stakeholders who were very responsive. Now, in terms of the nature of the feedback that we collected, I would say there are three main brackets that we engaged about. The first one, as I mentioned, was what they think honestly in terms of the benefit that they see of such a system. The second one was the concerns that they could see for themselves or for people. And the third basket was recommendations on how to move forward. So looking at the first basket, the benefits, I have to say that overwhelmingly, stakeholders expressed a positive opinion about what we were trying to achieve. So they could see clear and tangible benefits to Project CAELUS. And if I go through, the verbatim, the report is essentially verbatim, so that because we try to be as transparent as possible, to really reflect what people told us, as opposed to trying to reinvent their message. So you see here some key verbatim. The fundamental benefits that stakeholders see is, of course, the societal benefit of better care, getting medicines to people quickly, especially to remote areas. This is a benefit of the speed of delivery for urgent items. This is a benefit of direct point-to-point transport. Having flown in Scotland, getting out to the islands make eminent sense. But it's not only in Scotland that it would be relevant. Scotland is not the only place with poor road networks. So if after this discussion and meeting, I will circulate the main report, and you will have the opportunity to see all the ideas that came up in terms of the benefit for society as a whole. Another very valuable one is the user case around a cancer patient who have to travel to the hospital 7 days a week, 7 days, in a row, stay in a hospital, and then come home for 3 weeks and then come back. So clearly, if we had the opportunity to transport their chemo drugs to their local hospital or their local GP so that they could stay at home, clearly the experience of the treatment would be very different. Second benefit identified is hospital efficiency. So moving drugs to just-in-time delivery, reducing wastage, reducing the cost of taxis that are often commissioned, especially for emergency deliveries, and also reducing the inventory of products that have a limited shelf life. Then beyond the societal benefits around the NHS, the second category of benefit identified is the environment, unsurprisingly, the ability to replace fossil fuel vehicles and to contribute to cities' zero carbon priorities. So clearly the environmental benefits, the reduction of congestion on roads has been identified as a major benefit by most stakeholders. And also came this idea that we could use a drone to also have sensors on it and monitor the air quality along the journey. So not only reduce the pollution, but also try and monitor it to support improvements in spotting areas where there should be more improvement. Another benefit is the sharing of infrastructures. And first set of infrastructure is communication, so 4G, but also 5G when we come to it, especially around airports or in cities. In Scotland, there is also the opportunity for the NHS to share the ESN, the Emergency Services Network, that will be available for emergency and public services. But also there would be opportunities of sharing the infrastructure with other general aviation systems. So to begin with SatNav, satellite communication, satellite navigation, but also electronic conspicuity, as well as airfields. Some airfields are struggling to stay open because the running costs are high. I mean, there could be opportunities to use those airfields as well for drones, for example, for training practices or for emergency landing. Reduce risk to personnel, and that is particularly true for emergency services, as opposed to sending a helicopter crew. It would be, better, especially in some specific circumstances, to send out at night, for example, or when the weather is challenging. It would be better to send a drone as opposed to sending a crew. And then it also means that the helicopter could be used to actually save people, as opposed to deliver emergency medicines when it's used for that purpose. Finally, there is benefits in terms of sheer innovation. I mean, the fact that we're looking at using drones to support a NHS logistics network means also that we will push the boundaries for BVLOS, also for data collection operations. So there will be other advances in technologies, for example, in terms of battery power, endurance, range, but also payload capacity. And I would say it will help shape the future of the overall systems that will be required for BVLOS operations. Finally, it can be a stream of career opportunities, including for experts from manned aviation. For example, pilots are, you know, in a nutshell, experts in terms of risk management, risk assessment, and risk mitigations. And clearly their skills would be very beneficial in the context of BVLOS operations and drone operations. Now, our stakeholders also identified public concerns, and I will go through those. In a way, we all know them, we've heard of them, but it's really valuable to, you know, to get the feedback from experts who are in the field and who go through operations today as well, and get the feedback on what they see on the road, you know, happening on the ground. So the first concern raised is noise and visual pollution. And it's true that if you suddenly find yourself on the path line between the hospital or the delivery warehouse and the hospital itself, and the deliveries are every day and they're every half an hour, that might be a real problem, and that is true. At the same time, you know, experts recognize that technology can address a lot of the noise issue, you know, starting by suggesting to noise manufacturers that they take into account quiet by design typically, and tremendous progress have been made in manned aviation, and there is no reason why similar progress could not be achieved as well for unmanned aviation. Also, it's recognized that the UTM, so the unmanned or unified traffic management systems, could also help noise mapping and essentially diversifying noise exposure or reducing noise exposure by optimizing the flight path. Environmental impact. It's all good to be using electric propulsion, but beyond that, we have to go and have at a broader perspective, on an end-to-end perspective. So the big question might be the overall carbon impact. What's the carbon calculated cost of flying things by drone versus maybe an electric car or an electric van that would be carrying a lot of samples in the van. There is also a question mark around birds and wildlife, and probably these elements would have to be taken into account when determining the flight path, also something to take into account as part of the UTM solutions. Privacy. As a citizen, I have concerns about some people might term as the spy sky, having more cameras surveying what we're doing. And actually, some of the comments came from public agencies using drones today for public services. And it was very interesting to hear that they do receive phone calls from people recognizing their drones and, you know, asking, why were you flying in my neighborhood? So it is an element that we should definitely take into account, that some people may be concerned about drones flying around the neighborhood and being concerned about it. Clearly, technology could be an answer to it as well. If we have complete situational awareness through the equivalent of the Drone Assist app or the equivalent, but made available for everybody in a very simple way, so that people can look at their phone on the app and identify that the drone flying in next to them is an NHS drone as opposed to anything else. Containment of criminal behavior. Our stakeholders recognize that we will always have people who wish to develop some kind of criminal activity. And that is true, you know, with smartphones, with cars, with everything. So we just have to take it into account. But it's true that drones have some vulnerabilities, at least for now. For example, they are more vulnerable to local jamming. So there may be some security and cybersecurity measures that should be taken into account. There are also some questions raised in terms of the medical aspect of security. And it's been mentioned that people can be concerned about the hacking, if you want, or the access of their medical data in case the drone itself has an issue. So anti-tampering and misuse of medicines or illegal access to medical record is something that should be taken into account when we really develop the operational application of the project. And the final concern that's been raised is not a foot in the door for less desirable applications. So I mentioned that pretty much every stakeholder was clearly recognizing the benefit and were in favor of a development of a solution for the NHS, subject, of course, to addressing the concerns that that people have or that they would have. But they also mentioned that it should not be a reason to use the solution for other applications such as last mile courier type of delivery, where, you know, some people consider that it may not be necessarily a good idea. Some may consider it a good idea, but not everybody. And so there needs to be, you know, a measure in that respect, or maybe a consultation before we expand beyond pure NHS applications. Also, it was mentioned that if you go straight to those applications that are contentious or controversial and difficult, like urban air mobility, then potentially you drive yourself out of your markets where there is clear benefits. So we need to be careful and ensure that it's not because a drone logistics network is applauded for the NHS. It doesn't mean necessarily that the same people would applaud it as well for pizza delivery, if you want. Now, looking at the mass of insights that we collected, and here I have to tell you that I strongly encourage you to take the time during your next lunch break to have a look at the report that will be circulated later on. It's fundamentally verbatim. It's been designed to be extremely easy to read, but it's also very, very rich because we had a lot of comments from a range of stakeholders who are actually pretty good experts in their domain. So trying to synthesize everything in a few slides is challenging. But what we can say is that, in essence, the recommendations highlighted 5 main enablers to the project. The number one is, unsurprisingly, safety. Second comes a regulatory framework. The third enabler is to develop a scalable business model. Fourth is to develop education, collaboration, and sharing with all the different stakeholders. And the fifth enabler is to start an activity and proceed step by step. I cannot go through all the comments. I will try and do my best to cover some of the major ones. So if we start by safety, here is the list of the different items covered under safety. If we look at the first one, airworthiness, robustness of the aircraft system, I think it's fair to say that the drone industry, in a way, is a different animal to the traditional aviation industry. And I like this comment made by a person who is from the UAS industry. So drone industry, I don't see as an aviation industry. I see it as a tech industry. And a tech industry doesn't stop innovating. It is continuous, relentless, as we see it with mobile phone technologies. And so with that in mind, you also have some other stakeholders who have some concerns. Disruption in the industry also disrupts the safety level that has been achieved after decades of learning. Traditional aviation started with a huge number of accidents. It was still a novel industry, but people accepted it. As it is now industrialized, acceptance of aviation accidents has now become effectively zero. Drones are entering that space where the acceptance of all the different insights that have been then collected with regards to safety. Some recommendations, start gathering data and metrics to create that body of evidence and to measure safety. Recommendations similar to crewed aviation, where we have accumulated, or they have accumulated rather, a number of flying hours and identify some recommendations in terms of how long it would take for certain key parts to be replaced or serviced. The non-experts often refer to as the road industry and the schemes for vehicles. So, for example, having the equivalent of the MOT, so a third-party check on the drone itself to make sure that it is robust and it's checked on a regular basis. So my recommendation is to read the report. I have only a few of them here, but I think they are, they are very valuable because it gives a sincere insight, if you want, of what the stakeholders have in mind. Then in terms of safety, something very specific to Scotland, but which is very true, is the weather and the wind. There can be some serious wind gusts in Scotland, so definitely the solution would need to take that into account. But it's not only in Scotland. I think there can also be some different environment in urban and in cities, in urban environments, when you can have wind corridors created by buildings. Safety, the safety culture and the incident reporting culture. I think it's probably important to mention it because it's a key reference in aviation, the just culture, the fact that it's okay to report a problem because then we can identify the reason for it and correct it and avoid repeating mistake. And it's something that may not be completely yet fully known in the UAS industry, and it's something that probably we would all need to further to develop so that we fast track some of the incidents, resolving some of the incidents that we could be sharing through, through reporting, essentially. Training and developing competencies. And here I would like to mention the point about pilots who could be partners and not necessarily enemies. I mean, certainly not enemies, because their daily job is risk assessment and they are super risk managers on a daily basis. And clearly their insight could be valuable when it comes to pushing the boundaries of what we can do in terms of US operations. Second piece, in terms of safety, airspace sharing and moving from airspace segregation to airspace sharing. So simple quote here: people understand that when you're trialing because you're not sure whether your solution works. So safety margins are increased. I think the community of general aviation understood that, but it felt that plastering big TDAs, temporary danger areas, is quite disruptive. So it needs to be done surgically when they're needed. So I think the overall community probably agrees with that statement, that we all together gradually will need to evolve from airspace segregation to airspace sharing. But of course, it's a journey. We won't be there overnight. A few moments words on sharing with other airspace users on the very low level. So general aviation, but I think it's also very interesting to hear is that the final quote, we operate light aircrafts and we recently changed the way we operate. We won't go down much below 3,000 foot because we don't want to meet drones coming up above their limits. So here, something we did not think about is that below below the 400 feet, you also have drones operating in the open category. And actually, it's something to be taken into consideration because current operators of manned and unmanned aviation, how shall I say, see it as a potential risk, or certainly a risk that needs to be mitigated when they conduct their own operations. Sharing with other airspace, a word about the emergency services, where they would need to understand how the project would operate. I mean, clearly, when they are out in the sky, it's because they too are are flying to save lives, and we would need to make sure that we safely share the airspace with the emergency services. I'll try and accelerate because we will never have time for Q&As. Another point about safety is why not trial a horizontal flight band between 400 and 600 foot? And I like that one, a form of corridor that is, maybe considered today as a buffer between the UAS open category and the manned aviation, but actually it may be useful to use what is currently a form of buffer, because it could be that there are not that many flights operating in that band, and that's actually the approach that's been taken in Rwanda for the very famous operations by zipline. So maybe that slice of airspace is a relatively safe and unused piece of airspace where we could start trials. Electronic conspicuity. So it's a big burning topic. Everyone is looking for it. We use different equipment and different systems. The aim is that everything must be fully interoperable so that we can all effectively see each other. So that quote is from a stakeholder from general aviation. So it's not just drones, it's for everything flying, but it raises also a lot of challenges, but it's recognized by pretty much all stakeholders that it's a key cornerstone in terms of safely sharing the airspace. Clarify the ownership of avoiding action and possibly amending the rule of the air. I can see from my cockpit, I can't see, sorry, from my cockpit, a 25 kilo drone. Even if I've got the evidence informing me that there is a drone, unless I could see it, I don't know how to take avoiding action. And it's true that there is this concern from pilots, from small or bigger aircraft, that even if we have electronic conspicuity and there is this message that there is a drone in their neighborhood, they need to see it, spot it, to actually know how to avoid it. And they're really concerned that, by the time they see it, it's just too late to avoid it. So really their approach would be to put the avoid responsibility to the drone system. There is also a question of the right of way, which is not clear in the rule of the air today, just because it had not been thought of at the time when the rule of the air were designed. Number two, key enabler regulatory framework. So the challenge is to crack the BVLOS challenge. And I think that's really where the future flight in the UK, the future flight challenge is to try and pave the way to help all move forward in that direction. So a few elements on the evolution of the regulatory framework and the fact that there are different forces here at stake. First one is that we need to have that impulse with commercial viability and public acceptance to consider changing the regulation. So there is a need for, I would say, both a business push and a social acceptance push, so that changes to regulation comes on top of the pile of priorities of Parliament. Of DFT and then Parliament. So it's important that we reach the top of the pile, so that they look at it and vote on it. Second point is that we will not necessarily change what the regulations do, which is to protect the public from aviation and enable the public to access services from aviation at a reasonable risk. But the idea is that the regulation would evolve so as to include and embrace novel use of the sky. And then there is this challenge that authorities can't predict what technology will be in 5 years' time. So it is very difficult for them to regulate. It's a challenge for the CAA. And I have many verbatim and many quotes in that respect. The fact that it's very difficult to just keep up with the pace of technology that is coming from maybe a tech background. So it's very difficult for the regulators to keep up with those technologies and develop the adequate regulation. So it takes me to the next step, which is question mark on regulatory capacity and resources. The regulator is going to be a challenge. It's the resource that will be the limiting factor. The biggest roadblock at the moment for this industry is probably regulatory. The regulatory capacity is probably the best way to put it. The teams at the CAA work incredibly hard. However, we do need to look at how we can give them the additional capacity in order to support this industry properly. So we just have to recognize that there is a lot of work to be done, and it's different work probably than and different technologies than what traditional aviation has been exposed to. I will skip the next couple of some slides so that we have time for a Q&A. Scalable business model. So number one topic is to factor in the cost of safety into the economic equation. So safety is expensive. The cost of hardware is a challenge. For example, the cost of an ADS-B transponder is £100. However, the exact same transponder, but certified for safety requirements, then costs £4,000. And then when you look at, there is a significant period of time where you have to go out and set up 1 or 2 key routes and build up a high volume of flying hours. And this is, with exemptions and many people on the ground, airspace observers, etc., etc. So the setup for now is very expensive. And we are in that interim period. Before that point, there will be a point when using technology, instead of a 1-to-1 ratio, we will have one drone operator to many drones. Then, of course, it changes the business model and the real value comes in. But before we reach that point, we reap the benefit of true automation. We have that interim time, which is now, and a lot of the companies in the industry find it challenging to fund it. So I will, if you're okay, I will skip this one because we won't have time otherwise for Q&A. Enabler number 4, education, collaboration, and sharing. And I think in terms of the collaboration, I would mention 2 in particular. One is the local authorities, because they can be very important in terms of supporting innovation and promoting good use of drones with the general public. So I would say it's both a defensive and offensive approach. It's defensive because you need local authorities to allow drone operations, in their area. You don't want local authorities to be not aware of it, concerned about it, and pretty much ban drones or not facilitating use of drones in their area. To the contrary, you want to engage with the local authority so that they see the benefit of it and actually try and innovate that evolution and just engage and embrace it. And I think there are a number of local authorities that are now on that journey. And it's very important to nurture those relationships because it will help all of us develop BVLOS and future novel use of drone operations. The second element of collaboration I'd like to mention is we encourage collaboration between the regulator and the industry so that we can solve the safety challenges together. Let's start and test in a safe environment, and let's learn together how the solutions could be safe. So I think it's very important to engage with the CAA, with the innovation team, so that that discussion takes place as opposed to promoting a safety case at the very last minute, and maybe having spent a lot of time developing a solution where there could be a showstopper. And if we had that conversation earlier on with the regulator, then they could have immediately flagged those showstoppers, and the operators or the innovators would have been in a position to adapt and change the roadmap. The fifth enabler is to start an activity and then proceed step by step. So typically connecting some remote Scottish places would be a start, focusing on a specific region to help develop that capacity, showcase it, stimulate that economic environment, and then surely we can do that. It's important that we start an activity going into production as opposed to many trials and TDAs. And if it's saving lives, then if it's saving money, then why the hell aren't we doing it? It's better to take little bites and understand what the next little challenge is, as opposed to shoot directly for a very all-encompassing project. So really the message here is to go step by step and to iterate, to think big, but to start small, and get more and more engagement and approvals, both in terms of the regulator and the public as well. So these are the key findings. I am sure that I have not made justice to all the findings that are in the report. Again, what I suggest is that I stop sharing my screen and that we open the floor to questions. I'm really open to any questions that you may have. We've organized that session as a meeting so that we could do just that. So if you would like to shoot your questions, please, maybe I will ask Elena to be the facilitator, but otherwise, please go ahead.
So thank you, Annelies. That was extremely comprehensive. Thank you. And there's definitely some great ideas, some recommendations, and you've clearly done a lot of analysis too of the whole process. So thank you very much for sharing that with us. Have we got anybody who would like to kick off the very first question? Do please feel free to unmute yourselves to ask the questions as well.
Helena, Steve Hutt, if nobody else has got one, can I ask one?
Of course,
sure.
Please go ahead.
Okay, very interesting. I didn't detect much, if anything, in there addressing the question of reliability of the command and control over 4G, 5G. Basically, if you're into remote areas, you can potentially have gaps in the coverage, which means you're outside of coverage. I've had my cell phone coverage at home here go down for a week at a time. In fact, literally days, just in this last month, it's gone down, and I've been without coverage for days. So I just wanted to just highlight that I didn't see much, if anything, in that report.
Yes, I would say that it's implicitly covered in the what I call airworthiness and robustness of the overall system. The reliability of the command and control system is, of course, an essential one. So I have to say that you will see in the report that there is, in several instances, this question mark on the reliability of the C2 link and what happens if you lose the C2 link. So, I mean, we know the answer there is that normally, depending on the solutions, depending on the systems, if you have a loss of C2 link, then you have a form of, emergency procedure happening, a return to home, or maybe emergency landing, but probably depending on systems, return to home. So it's different from those findings. I would say, of course, you are very, very right that it's a very important topic. I don't know if you've seen the Ofcom consultation. Ofcom put out a consultation where they offer to have a license for drone operators, let's put it this way, to allow for, to authorize the licensing of 4G and satellite com for BVLOS. So that would be the redundancy. I guess the idea would be that if you have both 4G and satellite, if you lose 4G, you go to satellite. And then if you lose both, I guess it will depend each time on the US manufacturer solution, but I suppose then you would fall back to a return to home or maybe an emergency landing.
Yes, I obviously I think you're possibly aware there was an incident that has basically highlighted this to the regulator. There was a drone, quite a large drone that shot off to 8,000 feet at Goodwood when it lost C2 and flew up into controlled airspace. So it is a big concern. It's great when it all works, but when it goes wrong, if it goes wrong badly, it can have dramatic effects. I mean, I must admit, I have to own up to a vested interest because I work for a company. I'm well aware of that consultation, and I work for a company that has a system which has aviation grade certifiable command and communication systems that actually address this issue. So that's why it's particularly pertinent to me.
Good. Well, so you mentioned Goodwood. I think the commercial pilot referred also to the Boeing 737 MAX in terms of reliability of software. I think Goodwood is not a great. I fully agree, not a great reference of things that should not have happened. Yeah. So going forward, I think for BVLOS operations, let's see what comes out. But depending on the types of operations, there will be requirements on reliability of the C2 link, and I doubt that the solution that was used at the Goodwood demo had anything of that order. But it also what you mentioned in terms of the reliability of the communication and the certifiability will definitely be part of the conversations that are going to pop up, because if you remove the pilot direct control, then and if the system or if technology takes over, then technology will have to be reliable. So I would be very we would be very interested in having a discussion with you, Steve, and your company and what you do.
Okay, I'll send you an email.
Great.
That's great. Indeed, command and control is indeed a fascinating topic and how it will affect this side of drone deliveries. Do we have any more? Please don't be shy. This is a great opportunity to ask all questions.
Nope.
Nope. It seems not. If you do have any questions that you don't want to ask here, please do feel free to contact Annelies. It's hello@the drone office, isn't it, Annelies? At thedroneoffice.com?
hello@thedroneoffice.com.
Brilliant. And that's absolutely fine. Or again, you can contact membership at ARPAS.UK and we would be more than happy to forward them on to Annalise too. In which case, then I think it'll give you a moment still to please don't be shy. And if not, then we will call a halt to this afternoon's proceedings. Okay, well, thank you very much, everyone, for attending, and we will follow up in due course. Thank you very much then. Goodbye.
Thank you. Goodbye.
Bye, everyone.
Thank you, Annalise.
Welcome.